For the polynomial below, -2 is a 0. Express f of x as a product of linear factors. So this question has given us one of the zeros for the polynomial f of x equals x cubed plus 6x squared plus 7x minus 2. And you want to note the degree, which is the highest exponent. So this polynomial is degree 3, which tells us we know there will be 3 zeros. And since we've been given 1, we need to find the remaining 2. So first I want to make sure you know the difference between zeros and factors. So we've been given one of the zeros. One of the zeros is -2. That means the factor is x minus -2, which many of you may go ahead and just write as x plus 2. So that factor theorem in general says that if one of the zeros is some number we'll call c, then the factor is x minus that 0, in this case x minus c. So we need to find the zeros, and then that will allow us to write all of the factors. We expect 3 zeros, so there will be 3 factors as well. So one way to approach this is to go ahead and divide the polynomial by the factor that we just figured out. So if we were to write down our options, and don't write this down quite yet, just listen so you can decide what you think is best for you. If you take this polynomial and divide it by the factor x plus 2, which we had over here, we created the factor x plus 2 from the given 0. When we do this division, we could do this with long division, or because the divisor here, x plus 2, because this is linear, and also because the leading coefficient here is a 1, we could also do this with synthetic division. And most people prefer synthetic division, so that's what I'm going to show instead of long division. So if we're dividing by x plus 2, we'll take that divisor, x plus 2, and set that equal to 0 to find the 0 of the divisor, which we already knew was -2. So -2 is the number we're going to put in the box. Now you can set up your synthetic division like this, or I've also seen people set up their synthetic division like this. It's the same setup, it's just whichever you prefer. And then we're going to list on top, in our top row, all of the coefficients of our polynomial. So our leading coefficient here is a +1, then we have a +6, +7, and our constant is -2. So we'll list those coefficients, 1, +6, +7, and -2. And again, if you were doing it this way, it would look like this. And then synthetic division, remember, is where you're going to bring down the first number. So we'll bring down the 1, and then we multiply that number by whatever is in the box. So in this case, we brought down 1, and we're multiplying that by -2. So 1 times -2 is -2. And then we add straight down. 6 plus -2 is +4. And then you multiply again by the value in the box. 4 times -2 is -8. And then you add straight down. 7 plus -1 is, 7 plus -8 is -1. -1 times -2, the number in the box, is +2. And we add straight down, which gives us a 0. Now this value at the end is our remainder, and if we get a remainder of 0, then remember that means that x plus 2 divided evenly into the polynomial, which we expected. We knew that would happen because we were told that -2 was a 0. Now these values that we're getting here at the end, these are the coefficients of the answer to this division problem. And because we began with an x cubed, then our result here will be an x squared. So this 1 is the coefficient of our next term. That would be 1x squared. It's always 1 degree less. And again, why that is so is because we were dividing an x cubed by an x, or an x to the first, in other words. So we'll end up with a 1x squared, and then a +4x, and then -1. And of course, we don't usually write the 1 as our leading coefficient, so that would just give us x squared plus 4x minus 1 as our result. So now we're going to set this equal to 0 and continue solving because we're looking for the remaining 2 zeros. And the result here is a quadratic equation. This is quadratic because it is now degree 2. And normally I would have you begin by seeing if you can factor this quadratic equation. But remember, if we're trying to factor, we're interested in two numbers that would multiply to give us -1 and add to give us +4. And there are no values that would work. Therefore, this would be a good problem to use the quadratic formula on. So in this case, we know that A is equal to 1. That's my leading coefficient. B is equal to 4. That's the coefficient of the x term. And C is equal to -1. That's my constant. So the quadratic formula is x is equal to -b plus or minus the square root of b squared minus 4a times c, all divided by 2a. So in this case, x will equal -b, so -4, plus or minus the square root of b squared, that would be 4 squared, minus 4 times a times c, and then all divided by 2 times a, which would be 2 times 1. So -4 plus or minus the square root of 4 squared is 16. Then I always just recommend that you count your negatives. We have a negative here times a negative, which is overall going to be positive. That way you make fewer sign mistakes because now you can just multiply 4 times 1 times 1, since we already took care of the signs. 4 times 1 is just 4, all divided by 2. -4 plus or minus the square root of 20, all divided by 2. But of course we want to simplify. And in this case, we need to be sure we simplify the square root of 20. Now there's a few ways of doing this. Sometimes people have been taught the factor tree method, but moving on into more advanced math classes, it is going to be more beneficial that you have different, more efficient methods rather than always doing a factor tree. So I always tell my students to think of perfect squares that divide evenly into 20. So let me scoot over here. Remember, perfect squares, for example, if we were to say 1 times 1, that would be our first perfect square. That's just 1. 2 times 2 is going to be 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25, and so on. So these are the first few perfect squares, and we're looking for one that divides evenly into 20. So in this case, it would be 4. So we can rewrite 20 as 4 times 5. That means we're really going to be computing the square root of 4 times the square root of 5, and the square root of 4 simplifies to be 2. So therefore, the square root of 20 is really the same as 2 times the square root of 5. So now we have -4 plus or minus 2 times the square root of 5, all divided by divided by +2. And then we also see that we can divide 2 into both of our terms in the numerator. And we have two terms. We have -4, and we also have the 2 rad 5. So I'm essentially dividing that 2 into the -4, which will leave me with -2, and then I'm also dividing the 2 into 2, which would leave me with a +1. So overall, I'm getting -2 plus or minus 1 rad 5, but we don't write the 1. We would just have the square root of 5. So these are my remaining 2 zeros. So going back up to the top, if we were going to list all of our zeros, we had the first 0, which was -2, and now we've just added 2 more zeros on. -2 plus rad 5 would be a second 0, and -2 minus rad 5 would be our third 0. So once you have your zeros, then you can create your factors, your linear factors. So once again, if -2 is a 0, then the factor would be x minus -2, which we already determined is equivalent to x plus 2. And we'll do the same for these next 2 zeros. And by the way, these 2 zeros, remember, we call these irrational zeros. We were given 1 0 in the beginning, which was a rational 0. Rational just means it can be written as a fraction. So -2 is a rational 0, but -2 plus or minus rad 5, those are irrational zeros. We would put those in our calculators, and our result would be a decimal that continues on forever. So my factor is going to be x minus the 0. In this case, that's x minus the quantity -2 plus rad 5. So there's our second factor. And then our third factor is x minus the 0, which is -2 minus the square root of 5. And those are my factors. So to finally answer the question, which said they wanted you to write the function as a product of its linear factors, then our final answer, this function, written in factored form, would be x plus 2 times the quantity x minus -2 plus rad 5 times the quantity x minus -2 minus rad 5. And you could distribute the negatives, but I would be fine with you leaving it just like this. This is the factored form of the original function.